What's up, guys? It's Air Stuff FPV here, and I got the Silver Guardian home-built FPV plane here with me to do an endurance flight with it. But before I do, I want to give you guys some specs on it. It got a 1.6 meter wingspan, and with a 4S2P lithium-ion flight battery, 9,600 milliamp hours, it got an all-up weight of 1.8 kilograms. Beforehand, it had the 4S 5,000 milliamp hours lipo battery, and its all-up weight back then was 1.6 to 1.7 kg, so it's a bit more heavy, but I got close to double the milliamp hours for lengthy flight times. There's a 411WTE flight controller back here, and here at the outside I got an 800 milliwatt video transmitter with a pagoda antenna. And this bundle here actually consists of the LED modules for controlling the LEDs that act as navigation lights here at the sides of the fuselage pod, and there's one at the tail as well. And right here I got a 750 kV motor spinning a 12x8, which is a very good combo with a 4-cell lithium ion or lithium polymer battery. And here at the back I got a Baytium BN220 GPS module, as well as the receiver and its antennas. It's the FrSky X8R, which does about 3 to 4.5 kilometers with this particular setup. So that covers the setup of the aircraft. If you want to build this particular FPV plane, I actually have a video on how I built it for you to check out here at the top right. And it might look different because back then I had a different tail design, but how I converted it into the VTOL that it now has is a separate video on its own that I'm also going to recommend you right now here at the top right. So right now I'm gonna get the ground station up, active, recording and going, and then make myself comfortable in the car after launching it in the air and see for how long I could actually fly it.
So this is rather a boring endurance flight since I let it loiter and return to home mode for the whole flight, because the autopilot is best at the throttle control, maintaining the altitude as efficient as possible. I'm aware that there are different flight modes with the same features like altitude hold or position holds, but I didn't configure them into the flight controller. At this moment in flight, I reached 1 hour and 30 minutes of loitering time, having consumed over 7,700 milliamp hours of capacity and total distance travel of 66 kilometers. The battery voltage being at 12.6 volts under load was holding strong, but my ESC started to limit throttle increase since it detected the individual cell voltage dropping below 3.2 volts per cell. And then finally at the 94th minute mark, the ESC didn't allow sufficient battery power to the motor anymore, and then I took control over the aircraft and brought it in like Ryanair. So if we have a look at the stats of the flight, we could see that it consumed 8,115 milliamp hours over a flight duration of 94 minutes and 56 seconds. And with these two flight details, I calculated the average amp draw of the flight to be 5.1, which I found quite good. It's dividing the milliamp hours by your flight time in minutes and then multiplying that by 0.06. And as a comparison to the Silver Eagle VTOL pusher, I applied the same formula to get the average amp draw from its worst endurance flight. So here we see 8,075 milliamp hours consumed over a flight time of 121.8 minutes, which turns out to be an average of 3.97 amps. And this comparison actually reveals the potential of the pusher, because the 5.12 amps of the tractor is the best it could do, while the 3.97 amps of the pusher is how it did in the worst conditions it could fly in. But nonetheless, I'm very glad to achieve a 1 hour and 34 minute flight time with the VTail carbon boom tractor design. The only day I'm waiting for is to know how long I could fly the pusher and flying wing, which are my two most efficient FPV platforms so far. But until then, I have to be patient. Thank you guys so much for watching, leave a like to support, and I hope you guys stay tuned to meet me in the next video.